What we're going to be discussing are, this lesson is what are called linear inequalities in two variables. And so we talked about linear inequalities before, but this is going to have two variables. And so the first example, top of page 27 there, x plus y less than or equal to 10. So we've got two variables still, but it's an inequality. So that's the main thing we'll discuss today. I've got several examples besides this one before I get to those last three at the bottom. But yeah, so what this means is, you are graphing a line still, because it's still linear, meaning x to the first, y to the first. You still got linear in that regard. And so you're still talking about a line. And so that's why I say start with that. And I really just kind of ignore, first of all, the inequality. Just graph the line. In other words, just do the equal to. And so we have graphed these, and the way we talked about graphing, there's lots of ways. I mean, nothing else, you can do a table of values and graph it that way, but the way we talked about doing it was make it y equals mx plus b, right? Which would be subtract the x, y equals minus x plus 10. And so that does give us a line. M is -1, and the b is 10. Of course, that's our y-intercept. So the y-intercept crosses up here at 10. So I should have marked it off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I did pretty good. Y-intercept of 10. And then if we use the slope as -1, that means rise is -1, run is +1. So down 1, over 1. Ta-da, you got your line. But that's just the equal to part, which we do have. What about the less than part? Well, what that amounts to is it's actually one side or the other of that line. All of the points on that side work as far as solving this inequality. And the good news is, so it's a whole bunch of points that satisfy this. The good news though is you check one of the points and you got it. Because if that point works, you know it's that side. If it doesn't work, then you know to go to the other side. So what I'm saying is check a point not on the line in the inequality. As the second step here. And usually the best one to check is 0, 0, as long as it's not on the line. And so what I'm saying is check it in the inequality here. Well, of course the x and y go there, but so you got 0 plus 0, and that's, why 0, 0 is nice, because it's going to zero out the x and the y term. And so what you're looking at is whether that or not that's true. So are we true there? Yeah. 0 is less than or equal to 10. That's true. So what does that mean? 0, 0 works. But what that also means, all the points on the same side of 0, 0 work also. Okay, so here's 0, 0. Everything on the side with 0, 0 works. So 1, 1 works, 1, 2 works, -1, 9, -1, -4. All these points work. And so what it comes down to is we're going to shade, yeah. We're going to shade the side of 0, 0. Of that line. And we're good. Okay? So that's pretty well the deal. Now, let me change the inequality, keep the same things, but change the inequality just a little bit. Let's go x plus y greater than 10. And talk about a couple of things there. Okay, so it's the same line that we had, right? Right? That'd be the same, I mean, still graphing the line x plus y equals 10. It's still the same line. However, what's missing on the inequality here? There's no equal to part. So what that means is for my line, the line is actually not a part of the solutions to this. Because I don't have the equal to parts of the line. You still need it though, it's a boundary, okay? So it's not actually part of the solutions here, but it is a boundary for our inequality here. Call it a boundary line. And so we're still going to put it on here, we're just not going to include it, so for that reason we dot the line. And so what was it, 10, and then -1, so something like that. So instead of solid line, we're going to go dotted line. Now, also, so it's a dotted line here. Also, here, if we check our 0, 0 point, what about it? 0 plus 0 greater than 10? No, that's false. 0 is not greater than 10. Okay? So 0, 0 doesn't work. Well, that means all the points on the same side of it don't work, but what it also means is the other side works. Because of that. Shade that other side of 0, 0, so it goes up here. So, anyway. Yeah, so if you have a, and it would have been the same, we would have used a dotted line if I just had less than here. So, here's the moral of that story. All right, so less than or equal to, greater than or equal to, those you use a solid line. Less than or greater than, use a dotted line. And that's simply because you don't have the equal to part on those, and so you don't actually have the line as part of the solutions. It's just a boundary. So points along this line don't work in the inequality because actually they would give you equals 10 on that line. However, you still need it to do the shading. Is that okay? Question or concern? All right. So like I said, what I mainly want to do is graph several of these, just to show you some different things that can happen, I guess. let me do another one here. All right, let's talk about this one. 3x minus 2y plus 4 greater than or equal to 0. All right, so again, step 1, graph the line. In other words, just the equal to, then we'll talk about the inequality. Just graph that line. So again, a number of ways you can do it, but we did it the y equals mx plus b. So just solve here for y. So I'm going to subtract the 3x and subtract the 4. Minus 2y equals negative 3x minus 4. Divide off the negative 2. So we got y equals 3 halves x. And then the thing is, you got to divide both of these by negative 2. So plus 2. 3 halves x plus 2. Good with that? All right. So we've got our slope is 3 halves. Our intercept is 2. Yeah, we can do the line here. 1, 2. Slope is 3 halves, so rise 3, run 2. 1, 2, 3. 1, 2. So there's our other one. Now on these, you have to say solid or dotted. What we got here? This one's solid or dotted? Solid, yeah, you got the solid. You got the equal to parts, so you got solid. But that's not nearly all the solutions because we've got the inequalities. So I say, well, what about the shading? And the way you handle that is just check 0, 0. As long as it's not on the line, we'll get one where you can't use 0, 0, but usually 0, 0, pretty quick check to get your shading lined out here. So if I plug in x to be 0, y to be 0, what do I got? 0 minus 0 plus 4 greater than or equal to 0. Well, again, sure enough, right? That's true. So I shade the side with 0, 0, which is to this side of, so 0, 0 works, so shade the side with 0, 0. Yes? So all these points, any point on this side of the line, also satisfies that inequality, and so, yeah, something like that. Is that okay? All right, now, let me do this one because it has a little something here. It's 3x plus 4y less than 5. Not too bad, but all right. So start with the line, 3x plus 4y equals 5. Well, we use the y equals mx plus b. Subtract the 3x, 4y equals minus 3x plus 5. Divide the 4. So that gives me y equals negative 3/4 x plus 5/4. Now notice in the homework there was a couple of them where this happens. All right, so I've got, that's not a problem. We know rise over run. We haven't done one, I don't think, where we had a fractional b. Of course, that's 5/4 is 1.25. So I'm going to go to the y-axis 1.25. 1.25. Okay, so right about there. Now, If I use my rise to run, I'm a little bit off because I'm not on a whole number, integer. But this is the same thing, so you go 1, 2, 3, down, right? So I'm right there for my -3, so about, what, negative 1.75, something like that. And then over 4, 1, 2, 3, 4. So you can still do it, it's just off of an integer, not a whole number there. So, but you can still use the rise and run. Just have to factor that in, being off the 0.25 there. Is that okay? All right. Solid or dotted? Dotted. No equal to, is there? Without the equal to, technically you don't have the line included, but you still need it as a boundary. So this one will be dotted. And then the last thing is the shading. Check 0, 0. See if it works. So we're checking it in here. 0 here, 0 here. That gives me 0 plus 0 less than 5. That's true. 0 is less than 5. And so again, we can shade the side with 0, 0, which is here. So it's down below. Yes? Sound okay? One other one similar to this is this one. Well, matter of fact, let me do this. Okay. X minus 3y is greater than 3 minus y. He's got some kind of different looking inequalities here. But again, for the line here, again, if I just do the inequality, the equation to get the line, it's just getting the y on the side by itself. So add the y, subtract the x, because you got to get the y's together. So that'll give me negative 2y on this side, and then minus x plus 3 on this side, if I put it in the proper order there. And then divide off the negative 2. So I've got y equals, all right, so I've got negative x divided by negative 2. Let's write it out. And then plus 3 divided by negative 2. So that, what does that give me? Slope-wise, positive a half, half x, and then b, negative 3 halves. So it's similar in nature to that previous one I just did. All right, so that's my y-intercept, negative 3 halves. That's negative 1.5. You're right about there. For my b. And then my slope is a half, so that would mean rise 1 and then run 2. Put it right about there. And there's my line, but dotted, isn't it? because you don't have the equal to part. Shading, check 0, 0. So I've got, go back to the inequality now, so I've got 0 minus 0 greater than 3 minus 0. Okay, so this one, not so much, is it? That's false. 0 is not greater than 3. So what does that mean? Shade the side 0, 0 isn't on. Shade the other side of 0, 0, from 0, 0 side. Right? So 0, 0 is on this side. I need to go to the other side. So this one is down below. Okay? All right. One more of these, and then we'll tackle those 3 at the bottom there. Of page 27. Like I said, I had a lot to do for that one. Got to those. All right, so this one is y plus 2x greater than or equal to 0. You'll see why I want to mention this one, because here's what happens. All right, so the line is just y equals 2x, y plus 2x equals 0. So that's just y equals minus 2x. Subtract the 2x to the other side. So what does that mean as far as my line goes here? Well, you don't have a b, so what's b? B is 0, yeah. There's no b, so b is 0. And then my slope is negative 2 over 1, rise negative 2, so down 2, run 1, positive 1, so right here. Underneath that point, and it has the equal to, so this one is a solid line. But here's why I mentioned this one. When I go to my shading part, what's wrong with using 0, 0? 0, 0 is on the line. So that's not going to help me with the shading at all, because I already know I got it on the line there. So yeah, 0, 0 is on the line, so I can't use it. So the next best thing, 1, 1. See if 1, 1 would be maybe, or as long as it's not on that line, it's useful. All right. So let's go to 1, 1. So I plug in x and y to be 1s. That'll give me 1 plus 2. Is that greater than or equal to 0? I do believe so. So 1, 1 works. Where's 1, 1? Well, it's right up here. 1, but it's on this side of the line, above the line here. It works, so all the other points would also work that are with it. So there you go. Can't use 0, 0, just use something else. And it doesn't have to be 1, 1, but something not on the line. Is that okay?